Welcome to today's lesson. Today we are defining a random variable. But before defining a random variable, I would like first to define a sample space. If we know what is a sample space, it will be easier for us to define and understand what is a random variable. So let's see what is a sample space. A sample space is defined as a set of all possible outcomes of a random experiment. Yeah, let's see this example of tossing 3 coins. The experiment of tossing 3 coins. If we toss a coin, let's say a single coin, there is a possibility of getting either a head or a tail. So what are possible outcomes of tossing now 3 coins instead of tossing 1 coin? Yeah, as I have been saying, if we toss a coin, there is a possibility of getting either a head, that's this a head, or a tail. So, but if we toss 3 coins, there will be 8 possibilities, 8 outcomes. But what are those outcomes? Let's try to understand these possible outcomes using these 3. If you can see these 3, once we start tossing our coins, there will be 8 possible outcomes. For instance, we may get a head for the first coin, a head for the second coin, and a head for the third coin. Or we may get a head for the first coin, a head for the second coin, but a tail for the third coin. Or we may have a head for the first coin, a tail for the second coin, and a head for the third coin. We may have a head for the first coin, a tail for the second coin, and a tail for the third coin. Or we may have a tail for the first coin, a head for the second coin, and a head for the third coin. Or a tail for the first coin, a head for the second coin, and a tail for the third coin. Or a tail for the first coin, a tail for the second coin, and a head for the third coin. Or we may only have tails. No head is displayed in neither one of these 3 coins. Then in this case we get tail, tail, and tail. So if you count these possible outcomes, 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So for this kind of experiment, what is the sample space? We define a sample space as a set of all these 8 possible outcomes. If we remember in mathematics how we write a set, then the set will be written in this way. Let's say we call it S. S will be a set whose elements are these 8 outcomes. Head, 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 tail, head, tail, head, head, tail, tail, head, tail, head, head, tail, head, tail, 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 head, tail, tail. Yeah, a set of these 8 outcomes. So the set S is called a sample space. To define a sample space on a given experiment, one needs to follow these 2 steps. The first step is to identify all possible outcomes. As we have done here, we identified all the possible 8 outcomes, and then you list them in a set. Yeah, we have to list all the outcomes in a set, and that set will be a sample space. Let's see another example. Consider the experiment of rolling a dice, a 6-sided dice. regular dice, of course. A regular dice of 6 sides. We have sides on which it's written numbers 1, 2, 3, 4, 5, or 6. So if we roll it and see what number is displayed, it may be one of the 6 numbers written on those sides, and it may be either 1 or 2 or 3 or 4 or 5 or 6. Then in this case, the sample space will be the set S formed by these 6 numbers 1, 2, 3, 4, 5, and 6. But when rolling 2 dice, we will get many outcomes, not only 6 outcomes, but 36 outcomes. But how? Since each of the 2 dice we have 6 sides, then to identify the possible outcomes, we can just do it. Let's try to use this table to understand it better. If we consider the row, this row, the first dice, and the column as the second dice, so if we roll both dices, we may either have 1 on the first dice and 1 on the second dice, or 1 on the first dice and 2 on the second dice, 1 on the first dice and 3 on the third dice, and so on, up to having 6 on the first side, on the first dice, and 6 on the second dice. So if you count all these possible outcomes, there will be 36. And yeah, you know how to count. Just we have 6 and 6 here. Then if we take 6 times 6, there will be 36. Then we have possible outcomes, number of possible outcomes to be 36. But what will be then the sample space? The sample space, it will be a set formed by all these 36 pairs and will be written as follows. Yeah, we will have S equal to 1, 1, 1, 2, 1, 3 up to 66. So now, since we know what is a sample space, we can easily define what is a random variable. To define a random variable, as I have told you, we need to understand what is a sample space, because a random variable is defined as a function that maps from the sample space of an experience to the set of real numbers. In mathematical way, we can write it as x, a function x, which takes values in S and take its images in R. Yeah, R, set of real numbers. So we have a function x, and it will take its values in the sample space. Its domain of definition is included in the sample space, and its image of definition will be included in set of real numbers. Yeah, having S being a sample space and R being a set of real numbers, and X will be defined as a random variable, not a sample space. Sorry, it's a random variable. So if, for example, we take a sample space, and in that sample space we suppose that our function x takes any different values from that sample space, then we can write that x will be equal to this set, and it means that x may take either value x1 or x2 or x3, yeah, up to n, because we say that we are saying that it may take n different values. So yeah, we have x which may take either one of those n different values. And to have x equal to a given value from these n values, there will be a given probability of getting one of those values. For example, the probability of having x equal to xi is equal to a given number pi, which should be between 0 and 1. Yeah. So, and we should know that if we sum all the probabilities of getting these values x1 to x1, the sum should be equal to 1. It means the probability of getting x1 plus the probability of getting x2 plus the probability of getting xn, it should be equal to 1. And as we know, the probability is always between 0 and 1. It can't go further. Yeah, outside of this. It cannot be outside of this interval 1 and 0. Yeah. Let's see one example. Let's go back to our experiment of tossing 3 coins. We have said that the sample space for that experiment is a set formed by these 8 possible outcomes. So if we denote x, the number of heads obtained when tossing 3 coins, what values x can take? If you see this sample space, yeah, look at it very closely, and you can see that x can take either value 0, it can be either 2, it can be 3. So x can take only 3 possible values. It may be 0, 1, 2, or 3. If we denote x, the number of heads obtained when tossing 3 coins, x can take 4 possible values. It may take either 0 if there is no head displayed, either or 1 if only one head among the 3 is displayed, or 2 if only 2 heads are displayed, or 3 if all coins displays a head. So one may ask himself, what is the probability of getting x equal to 0? If we come back to this set S and see where we have no head, you will see only here only one outcome in which we have only tails. There is no head, just one outcome among the 8 outcomes. Then the probability of getting x equal to 0 means no heads. It will be 1 out of 8. And what will be the probability of getting x equal to 1? What is the probability of getting only one head? The probability of getting only one head, it will be the number of outcomes in which we have 2 heads out of the total number of outcomes. So where do we have 2 heads? If you see where you closely, you will see that at this outcome HHT we have 2H, means 2 heads, and at this one HTH we have also 2 heads, and at this one where THH then we have 3 outcomes in which we have 2 heads. Then the probability of getting 2 heads when we toss 3 coins is to 3/8. And the probability of getting x equal to 3, in this case, it will be equal to 1 because it's only one outcome, H. When all the coins displays heads, just one outcome among the 8, then the probability of getting 3 heads is 1/8. Yeah, that's how we define a random variable. We first need to have a sample space, then from the sample space we map a function from values taken to that sample space to values in a set of real numbers. Any function of that kind is called random variable. So now that we know a random variable, I may give you a homework. You will go to the comment and let me know what are possible values of a random variable which is defined as the sum of numbers in a pair outcome for the experiment of rolling 2 dice simultaneously can take, and what are the corresponding probabilities for each outcome. Go to the comments and just let me know what is your solution. Yeah. That's enough for today. I think every one of us can define what is a sample space and what is a random variable. Yeah, those who are new on this channel, I recommend you to go back to my first videos and review them to understand better. Thank you for watching. Bye.